Okay, welcome to day one of Unit 4. This unit is called derivatives. So the first thing I'm going to talk about is average rate of change, or what I call AROC. So we've done linear functions for a long, long time. Y equals mx plus b. Not my favorite way. My favorite way is y equals m, parentheses x minus x1 plus y1. And what do these two things have in common? What is the most important characteristic of all time? Slope is number one. It measures change. And hopefully you remember the formula for slope. It is ingrained in your head. Change in y over change in x, change in output over change in input. Y2 minus y1 over x2 minus x1. Or this very special word we call the difference quotient. And the rate of change plays a very important role because it is a relationship between two changing quantities. Very, very important. How things are changing. So in Algebra 1 and even Algebra 2, you talked about linear functions. They have a constant rate of change. If something is linear and the slope is 2, it is 2 everywhere. Whether you take 2 points that are close together or far apart, it's always going to be 2. But any function, whether it's linear or curved or whatever, has a average rate of change. It's just the average rate of change between any 2 points on the curve. So as an example, my average rate of change for what we're doing here is 240 miles over 4 hours. I get 60 miles per hour is my average rate of change. Does that mean I went 60 miles per hour the whole time? No. Here's 240 miles. Here's my time of 4 hours. And I started at 0, 0. I ended up here. And I could have gone many different speeds to get there. Now, I do agree that the average rate of change is 60, which is the slope of this red line, but it doesn't mean you always went 60 miles per hour the whole time. So we're going to talk the difference between what a secant line is and what a tangent line is. A secant line passes through 2 points, and if you look on this blue function that's curved, the secant line goes through 2 points on this curve, while a tangent line only really touches 1 point on this curve. And we're going to talk about how a secant line and a tangent line, one is an average rate of change and one is an instantaneous rate of change. So if we look at this other function, the secant line, this slope is the average rate of change between the points A and B, where this is point B comma f of B, and this is point A f of A, as opposed to this slope here is the instantaneous rate of change just at this one point C. So a tangent line is an instantaneous rate of change, and a secant line is the average rate of change. And for secant line, I'm basically just doing this formula right here. Change in y over change in x between 2 points. Now I've done it purposely where this red secant line and this red tangent line are parallel, because that's what we're going to work on. And therefore, if they're parallel, they have the same slope. So I've completed the table for f of x equals x squared. I plotted all these points, and I've drawn the graph over here. And now what I'm going to do is figure out some average rate of change, or some secant lines. And the first one I'm going to do is between x equals 1 and 3, and I could just look at the table. I have the 0.11, the 0.39, and my average rate of change is equal to 9 minus 1, change in y, over 3 minus 1, the change in x, 8 over 2, so my average rate of change is equal to 4. I also have to write the equation. Again, when I write the equation, I do y equals mx minus x1 plus y1. I could use any equation that I want for this one. I'm going to use, or any points. My slope is 4x minus 1 plus 1, or I could use the other point, 4x minus 3 plus 9. It doesn't really matter. But what I'm going to do is I'm going to connect these points, 1, 1 and 3, 9. I'm using a straight edge, so I'm just putting the straight edge down. To the best of my abilities. Okay. So this blue line is part B, and my average rate of change is equal to 4. Now for part C, I'm going to do the tangent line parallel to the secant line, which means I have to have the same slope. So my ROC is equal to 4 still. And the way I do this is that I take my straight edge, and I just slide it parallel. If you ask me in class, I'll show you how. I just barely touch that graph. So this part C, my average rate of change is still 4, but now it's going through the point 2, 4, so it's through the point 2, 4. So when I write the equation, I have y equals my slope of 4, x minus 2 plus 4. So now I'm going to do part C, where I have different values. I'm going to use purple between x equals -3 and x equals 1. So that's -3, 9, and 1, 1 from the table. And my average rate of change is 9 minus 1, -3 minus 1, 8 over -4. So my average rate of change is equal to -2. And I could use any point I want. So y equals -2, x minus 1 plus 1, y equals -2, x plus 3 plus 9. But I am going to go up and draw this on the graph. So I'm going to make it bigger just because it's easier to draw. And I'm doing this point here and this point here. And now I'm going to take my ruler the best I can. And here is part D, where my average rate of change is equal to -2. And then for part E, I'm doing the line tangent line is parallel. So again, my average rate of change is going to equal to -2. So I go back to the graph. I'm going to draw parallel. So I can show you class. I take my ruler and just slide it parallel. And this is part E. The average rate of change is still -2. And I see that it's going through the point -1, 1. So I'm going to use that for the equation. For part E, it's going through -1, 1. Y equals -2, x plus 1 plus 1. And that's how we write equations and doing tangent lines and secant lines. So in this last piece of notes, we're just talking about in general, and I have this point A and this point B, except I'm not calling this A f of A. This is X, so this is F. Excuse me, let me erase that, it's messy. This is X, comma, F of X is that point. And this point here, well now the X value is X plus H, comma, F of X plus H. And we're trying to find the slope between those 2 points. Well, the whole idea is that the distance between each point on the X is H. So when I do slope, my average rate of change in Y over change in X, equals, well, Y2 is F of X plus H minus the first Y, F of X, over X plus H minus X. If I notice in the denominator, these X's cancel out, and I just get this formula right here. My average rate of change is the change in Y over change in X, and the change in X is just H. And now we're going to work on this, and this is a lot of algebra, and I made you do this a lot last year. Made you do this a whole lot last year. So I'm working on, this is my average rate of change. This says F of X plus H means plug in X plus H minus the original function. Let's try a couple examples. My average rate of change is equal to 5, parentheses, X plus H minus 2 minus the original function all over H. Okay, now I hit to distribute. Equals 5x plus 5h minus 2 minus, oh, distribute this negative sign, minus 5x plus 2 all over h. Now this is my favorite part. Okay. Everything in the numerator without an h will cancel. If it does not cancel, you got to say to yourself, I did something wrong. So when I look at this numerator, no, h cancels. No. Here's its buddy. No, h stays. No h, cancel, it's got a buddy. And now I have 5h over h, and the h's cancel, so I get my average rate of change is equal to 5. I knew that at the beginning, because this function is a linear function with a slope of 5, and another word for average rate of change is slope. Okay, the next function is a pretty easy one too, just x squared. So when I do f of x plus h, it means I plug in x plus h in for the x. So it's x plus h quantity squared minus x squared, the original function, all over h. Now you have to expand this. If you don't know what x plus h squared is, then do x plus h times x plus h and expand it out, or just memorize it that it's this minus the original function over h. The best step ever, things start to cancel. Does it have an x? No, it's got a buddy. Has an x, doesn't cancel, has an h, doesn't cancel, has an h, doesn't cancel. So now I have 2xh plus h squared over h. And if you want, you can factor out an h. Okay? Or, so these h's cancels, I get my average rate of change is equal to 2x plus h Or you could see that this H has to cancel out a 1H on every term. So this 1H cancels out 1H here, and it cancels out the 1H here and turns it into a first. I get the same results right here. Okay, work on your daily assessment. Ask me questions. We're submitting papers this unit. Thank you for watching this.